we have John Ellis, who is a do-it-yourself robot hacker and machine educator.
Hi. Let's see. Yes, so we are going to, give me a second here. I swear. All right, so hi. Thank you for that patience there. All right, so I'm going to talk to you today about another kind of real-world data problem that's I think is really fun to solve. Piloting robot cars in a road-like race course. I'm very excited about this stuff because it lets us do some what would be dangerous things, but they're not because it's 1/10 scale. I've hit a lot of people with my car. I'm trying to say that I've hit a lot of people, but it's okay. They were all fine. They laughed it off. Anyway, it's a lightweight vehicle. We've got a race course out in Oakland. We do once a month. We all get together and we do races on it, and we try to see who can be the fastest vehicle. The way that our team approaches that is with a technique called behavior cloning. There are a bunch of different techniques you can use to do robot car piloting. SLAM is popular, line following is popular. Behavior cloning is a very low barrier to entry process. It's very good at lane following. It doesn't give us the peak performance that we'll ultimately want in terms of vehicle avoidance, but it does get us something that lets us do a lot of work with real world data, virtual modeling, and building up towards something. And it's something that you can do too. And I want to emphasize that a lot. On the right there, we have a example of our data labeler system. So that's one of the downsides of doing a lot of kinds of machine learning is data labeling. Having a nice, easy to use labeler system really expedites that, makes it very easy to pick out what's your good data, what's your bad data. So bad, good, bad, good. Making that labeling really easily is really important. We actually, that's on our project. You can pull that if you want. The tool chain that we use is we've got a couple of input devices. So camera is our primary focus there. Using that camera data gives us a very rich amount of data that we can then work with. And we're breaking that down using OpenCV and V4L2 capture. V4L2 capture hasn't been upgraded in 4 years, but it works on Python 3. We're very happy about that. We also have a gyroscope that we can use to give us some dead reckoning aspect of it, a little bit of a, did we go where we wanted to go? Are we stuck? Maybe we're stuck. I think we're stuck. And then, of course, we have a controller input to provide a human labeling process. So one of the fun things about behavior cloning is that you drive the car a lot, and that's how you build your labeled data set. Our decision making is done with a TX1 from NVIDIA, but you can do this remotely as well. So a lot of other teams will do a remote transfer to like a laptop or their home computer even. And then output is just a real simple microcontroller into servos. So different kinds of hardware configurations. The most popular one is the donkey car. So for $200, you've got a car, a Raspberry Pi, camera, and 3D printed shell. And with that, you will definitely be able to get around the track. It's built for picking it up and doing it. They've got a really great project page that gives a lot of resources on how to get started into this. And so if you're curious, if you haven't decided what you're getting for Christmas, I'm not saying do it, but I'd love to see you out there. If you want to get crazy, and by crazy I mean crazy awesome, then you can upgrade and go for putting a GPU on top of your car, and then you do all the processing right on board, which cuts down on delay time. And if you're into controls, you know delay is bad, very bad. So that's a nice thing to have there, is to be able to just do it all in one package. But the most fun I think about this is honestly virtual to real world transitions. And so to achieve that, we have two different things I'm going to show here. So this one on the right is a virtual test environment that the Donkey Car team set up. So they've got a bunch of different racetracks built. And as you can see, someone is piloting this car. This is definitely not autonomous on the right here, but they've made a nice video showing what they can potentially train a car with or to handle. And they built that using Unity. So using a graphics engine is a really good idea. I highly recommend using a graphics engine for your virtual environment. I built a simulated environment using NumPy and Skykip image, which was fun. I'll admit, it was very fun, but has its limits. And so what we're doing on the left here is virtual training generation. So we're generating virtual training data, labeling it automatically, adding lots of geometric noise, and then the result is a model which successfully is able to recognize a real-world environment from a camera. So this is what really excites me. But I want to see you guys out there. I want you guys to join us because look at how much fun this is. Come on. Come on. Thank you. Thank you, everyone. This has been great.